Let's see where we left off here. We did Facebook, YouTube, branding yourself, revenue models, earning potential. Okay, so this is about where we need to get started. So we already covered basically the YouTube model, how you can make some money off it, how other people make money off it. Now we'll talk a little bit about databases, and eventually we'll get into cookies as well. So how YouTube decides what to present. Just like Facebook, it's going to show you content that people interact with. So, for example, all else equal, it's going to show you a more popular video versus a less popular video. Anytime you go to YouTube and you watch something, you'll have a list of other alternative things you can see in the margin. And of course, it's also going to show you content that others with a similar profile have viewed. So, for example, let's see what the kids have been doing on this machine lately. If I go to YouTube and I see, let's see, what do we got? A lot of that. Okay. So say I watch some Family Guy. All right. If I watch a Family Guy video, of course, there's going to be a lot of other Family Guy videos here in the margins, and something else, some Abbott and Costello, weirdly, some other Star Wars stuff in the margin. Anyway, part of this is trying to figure out what's related. Part of it is figuring out what's not related. So we got a few things in there, a little bit from Full Metal Jacket. Anyway, so it'll offer you up stuff that's similar. So the whole process is quite similar to a Facebook feed, where once you click on one thing once, it's going to start snowballing and show you a lot of similar stuff. So for example, let's see, what could I look for here? The duck song. Okay, if I click on the duck song, then boom, I'm going to start seeing a lot of duck song. We got all these kids videos on the side. Anyway, so that's what we have. All right, so short version, the process is basically like Facebook and Amazon. It's like a recommender system for other videos, and it's like Facebook's feed in that it's going to show you things that it thinks you're interested in. Now, in order to do this, it requires some kind of initial baseline and then some sort of continuous updating. So for example, if your profile changes, if you click on a few videos, I have a limited data set on this YouTube, but of course, the more stuff you watch, the more it has an idea of what you are interested in watching. It'll start showing you a mix of stuff. Likewise, if you have new video releases coming out, well, YouTube has to figure out a way to integrate those into the options it shows you. Now, just like Facebook, immediate consistency is not terribly important, right? This doesn't have to be a perfect recommender system that instantly includes all data from all possible sources. It's better to cut some corners and deliver slightly imperfect results quickly than to spend a lot of time trying to, super optimize what they're doing, because there's a fair amount of guesswork and experimentation in any event. All right, so if you go to the YouTube landing page, right, so let's see, I'm going to clear all my internet history and I'll show you a base landing page. So let's go up here. Go up to Firefox, we'll clear everything, and we'll get a completely clean slate here. So where's I don't even know where to do this, it's been a while. Options, privacy and security, there we go. All right, so we're gonna delete everything. All right, we're gonna clear it all. Boom, yeah, boom, everything. Whoop, sorry, I need to do longer window than the last hour. We're gonna do everything, boom. So we're going to go, and now if we go to YouTube, we're going to see a completely blank slate. So as if nobody else has ever used this thing before, I think. There we go. Now we get a bunch of random stuff here. So we get Christmas stuff, we get dogs adopted, we get some cartoony stuff. I don't know, Billie Eilish, I'm probably pronouncing her name wrong. Random cats, sports, Family Guy. All right, there you go. So we get this kind of stuff. Okay, now if I click on a couple things, I don't know, let's click on a Family Guy bit here. Once I click on this and I click on another thing, if I go back, I say, okay, yeah, I watched some stuff. I go back to YouTube. It starts to integrate that. So right off the bat, it says, hey, here's some stuff that you might be interested in seeing. So it's learning a little bit about me. Now, if I click on that a couple more times, I click on a little bit there, and I say, yeah, okay, whatever. I have something with the dog and watch a little bit. And we get one more. So I get a few more data points in here, right? And I close that out. Let's go back to YouTube. Fairly quickly, it starts implementing that in the data it keeps about me. And we get a new one here, Family Guy No Cuts, and some more Family Guy down here. Right, I scroll around, there's more Family Guy. So it all creeps in, right? And there's a Simpsons, which is, you know, pretty similar. All right, so we can understand how that works. Based on your profile, what you've done, it automatically adapts. So if you first visit YouTube, you get some kind of standard mix of whatever content is locally popular in your area. So it connects you to your data center. It says, well, we don't really know anything about you, but here's a bunch of stuff that other people have recently found interesting. And we're going to see which of those things interest you enough to click on. And that way we can build your profile a little bit. So two things going on here. Number one, like Amazon, YouTube wants to make it easier for you to find interesting content. Like Facebook, YouTube wants to show you a customized mix of interesting content, right? But until YouTube knows what you actually want, they can't do much about that, right? They just have to live with live without having much knowledge. So each time you view a video, YouTube tracks that action, adds it to your history. So part of that is the individual history things that you've done, and of course part of it is the baseline that goes on for your region. But all that stuff together, everything you've watched, ultimately composes your profile, and that gets continually updated every time you watch something new. YouTube stores some data about you and says, oh, here's a list of things you're interested in. They can apply that to show you new videos, and that's a kind of learning. So YouTube is learning about you in order to show you better options. Okay, so let's talk about learning systems a little bit. We haven't gotten too deep into it, but you've probably heard of things called machine learning, for example, which is one type of learning. Anyway, core idea for learning systems is there's some default baseline. There's some baseline assumption that we don't know anything about you yet. Here's what we're going to do. Then over time, they gather relevant information. And with more time and more data points, you can gather more information to find a reasonably good solution to some knowledge problem. In this case, knowledge of what videos are interesting for you to click on, how long you keep watching them. That's going to be information that YouTube has to show you new offerings. So anyway, every time you come back to the site, you start getting more and more accurate video options about things you might be interested in watching. All right. So essentially, this is what's called machine learning. This is one implementation of what's called machine learning. Machine learning is an automated process for producing a set of rules for predicting an outcome. So essentially, by watching what you do, YouTube is going to apply that information to develop some rules to show you certain kinds of data and not certain kinds of content and not other kinds. So for example, suppose there's a sequence of videos, parts 1, 2, 3, and 4. And most people who watch parts 1, 2, and 3, they're probably going to keep on going and watching part 4. So that would develop into a rule, essentially, that people who have watched these first 3, they are very likely to watch the 4th one. People who have not watched all 3 are unlikely to watch the 4th one. So YouTube essentially provides a 2-stage recommender system here. First, it pulls a subset of several hundred videos out of billions that YouTube says, let's throw some stuff against the wall and see what sticks. Second, just like Google, it takes that subset and returns the entire ranked list. It's actually very much like Google's operation for throwing you a set of links matching a set of search terms. So again, just based on what your profile is similar to entering a set of search terms into Google, and the results you get, a bunch of links to videos, very similar to what Google does in terms of returning possible options. Now, big issues here. Number one, scale. The bigger it gets, of course, just like Google, it becomes more work to sort through all the data and try to figure out what's important and what isn't, what's a good recommendation, what isn't, and keep track of all that for all of YouTube's literally billions of users. Second, freshness. So of course, interests change over time. You might have a short burst, for example, where you're binge watching some set of shows and then you're done with it and you're not really interested in ever seeing it again. So even though you watched it a bunch, YouTube should figure out, oh, this person finished off with that series, they haven't come back to it, we're not going to keep showing them that in the options. We can show them some better stuff. And of course, noise. So just random data. For example, if you have a shared computer, an intermittently shared computer, of course, people can go onto YouTube and watch things that are not necessarily indicative of your preferences. And then you come back and you're like, oh, this is some weird stuff in here. Like we would have that in Netflix when our nanny would watch stuff. And, you know, we'd say, why is this showing up in our set of options? But yeah, it's like she watched some different stuff from what we did. So whatever. Okay. Now, YouTube also includes a fairly minor random element in its recommender system. So if I go to watch some fairly widely watched video, let's find something here. Like the big one from some years ago was Despacito, right? Despacito. And let's see, this one, where's, it used to be one with 6 billion views. I don't know. Whatever, it's not there. Let's find something. Let's find some Lady Gaga. Let's see what we get. Poker Face, does that still show up? All right, that's got like 1 billion views. Good, that'll work. So I started watching this for a minute. I could see a whole bunch of other things popping into the stuff on the side here. So we got, you know, some random stuff here with lots and lots and lots of views, right? So here's one with 1.6 billion. Jesus, Katy Perry with like almost 3 billion there. I can scroll down, but I eventually can find some stuff that's a little bit off. For example, a version of TikTok with just words. I guess that's a karaoke version, right? And then if I scroll down, do I find some other relatively low volume ones? Nothing crazy low volume here, right? But sometimes you can watch some of these and they'll throw some oddball ones here. But definitely they're not trying to show just based on the highest number of views, right? It could be highest number of views within a recent window, for example, within like, say, the last month. We don't know exactly how YouTube picks the videos, but yeah, a lot of them are pretty popular. I'm just scrolling down here trying to find some that have not much numbers. Anyway, all right. Well, every semester is a little bit different in what we see. So there's always some amount of randomization in the recommender system. So part of that is suggest interesting but hard to find content, stuff that, you know, YouTube doesn't have a lot of data points on. They try to throw something out there, say, hey, maybe this is something you're interested in. Who knows, right? And it'd be like 1 or 2 things out of the couple dozen on the margin there. Another purpose, lets trending videos compete against older ones. If YouTube just looked at the number of views, well, of course, the older videos that have billions of views are going to pretty much block out everything else. But if you've already seen them a bunch of times and you're not that interested, then YouTube's going to be giving you worse recommendations. So by including some less popular but maybe trending videos, that's an option too. That can get an option to deliver people more interesting content. Of course, another thing, gain broader knowledge about user preferences. So the fact that, yeah, most of the time if they throw you some oddball thing in the recommendations, you're not going to click on it. Sure, that's kind of expected, but once in a while you will. And if they get that, then they learn something potentially important about you. For example, there was a song on the side here, which is about as unlike, you know, a Lady Gaga song. So they had some AC/DC song in here. I saw, if I click on that, where did I see that? If I click on that, then suddenly YouTube is going to think, wow, that's really weird. Here's somebody who watched Lady Gaga and AC/DC, and that's an unexpected connection, right? So if you do that, boom, you get all this kind of AC/DC and related type stuff there. Anyway, it completely switches over what YouTube thinks your profile is. In fact, now if I go back and I've clicked on a couple videos, I could see something really interesting. Let's see, we probably still have some Family Guy. Yeah, we got some Family Guy. Well, we got Poker Face showed up. That's good. A little bit of music, some Adult Swim, more Family Guy. Interesting. Anyway, it's just always interesting to see what YouTube's best guess about you is. Right? And the further you go down, you know, the more kind of random stuff it is. But okay. Anyway, the last thing about experimentation, it quickly converges to preference changes. So if you are a person who you're really interested in some band or some TV series for a while, you watch a bunch of it on YouTube, then after a while you're kind of done with it, YouTube can fairly quickly learn that, oh, you're no longer quite so interested in that. We can begin to phase that out of the recommendations. So experimentation serves 2 deep purposes. Number one, to break out of these circular feedback loops where the fact that you've watched something in the past and other people have watched it in a lot in the past makes it difficult to break out of that. So if there are a bunch of videos that all have about 3 billion views and they all came out at a time, they were all popular, a lot of people who watched A also watched B and C, there's going to be so much inertia with that data as a prediction that it's going to be tough to break out of. It's going to take longer, even if people haven't been watching those videos so much lately. So without that kind of experimentation, YouTube's recommendations would become too bound by inertia, too much based on past data, and without it to break out of it. Okay, now YouTube's database systems, next thing. So first of all, YouTube has sort of a relational database system for how it stores its video segments. We talked about Dash, and even though relational databases, they don't always work for video data, the fact that YouTube is able to segment the videos into same size chunks makes it a lot easier, that the various record entries are about the same size and reasonably appropriate for storing in a relational database. However, there's a whole bunch of extra tweaks on it. So this is an article from a few years ago, but just to discuss how much it would cost to run YouTube on Oracle's kind of traditional relational database system. If you're interested in this stuff, yeah, you can dig through it, but damn it, too many ads popping up though. But the short version is, it says, yeah, you could do it, but it would be super, super expensive, right? Oracle would say close to $600 million compared to what could be done outside of Oracle for a fraction of that, for only about 100 million. Anyway, interestingly, the ratio remains about the same for Stack and for support services. So for Oracle, they estimate about 100 million per year versus about 15 million for doing it open source. So anyway, the point is, all this stuff that YouTube is doing, you could do it with ordinary relational database systems and proprietary hardware models, stuff like that. But open source tools are sufficient to do the job and much, much cheaper. So YouTube is able to take advantage of that. And, if they were a much smaller operation, it might not be such a big deal. But since YouTube's, most of its business is managing all that video data, then those expenses become pretty central to its operation. Okay. Another interesting reading. This is about lessons in eventual consistency. Again, it's from a few years ago, but the data, the big points in it are still relevant. Let me get rid of some of this. Okay, key things to talk about here in terms of scalability. So YouTube, because it's so big, it has to manage scale successfully. It has to manage, its billions of users, certainly millions of people simultaneously logged in at any given time. A lot of what makes it possible for YouTube to do what it does to manage that scale is essentially to not insist on ACID properties, to not make sure that every piece of data everywhere in their system is perfectly synchronized unless it really, really needs to be. So a few things here. Well, one thing I can mention, let's see, I get an approximate correctness. This is a good one. This is about eventual consistency. So imagine this. If I go to a YouTube and I watch a video, and I don't really care what it is. Let's see what we got here. Okay. What the hell is that? Okay, I'm just going to pick something. Let's see. I want to see vaccines. Jackie Chan. All right, we'll watch a few seconds. Okay. Now, you see the view count on this, right? 2,338,601. I've started viewing it. If I view it again, it should have gone up by 1. But it doesn't. I view it again, it doesn't go up. But if I come back to it and say a minute, that number will tick up. So the point is YouTube doesn't simultaneously update the view count for every video because it has so many videos and so many people watching it. And what's really the point, honestly? Is SpongeBob going to come to my house or not to my house? Is he going to go over to YouTube and sue them because the video count view didn't instantly update? No, eventually it'll update. Let's see if they did now. Now, sometimes it can take a little while. It could be like a few minutes between updates, but it will eventually be updated. It's just there's no big rush to keep this perfectly consistent. So it's close enough, right? So they say here, if the user can't tell a part of the system is skewing and inconsistent, then it's not. So one thing, you don't have to have globally consistent transactions, right? You don't have to make sure that once you start watching a video, it instantly ups the count for everybody who might be watching it. Same thing for writing comments, right? If you write a comment, someone loads the page at the same time, they might not get it for a while. The person who's reading the new page isn't really going to care. It's not that important that every user instantly sees that comment. What is important is that the user who wrote the comment sees it. So again, system doesn't have to have globally consistent transactions. If you try to enforce that, it's going to slow down your system a lot, because essentially every update process is going to have to wait for every other part of the system that might be involved to finish that operation. So individual operations that the local part of it, the part that the individual user would see, those could get processed really quickly, but instead you wait for the whole global system to be done, and everything slows down quite a bit. It's better to wait for time periodically to to do some kind of batch update. All right. Here's one, for example, okay? Again, same thing like I was talking about, how to fake data. The fastest function call is the one that doesn't happen. So if you have a monotonically increasing counter, like movie view counts, profile view counts, you could do a transaction for every update, or you could say, you know what, this video typically gets about 10,000 or 100,000 views per day. So we're going to update it for about 10 or 100 or 200 views every minute, and every so often we're just going to update to that count. And if it gets a little bit out of whack, well, we'll figure that out later. Okay, but you don't have to call some server for every update for watching the video count to update it by one. All right. Anyway, so stuff like that, there's a lot of places where you can cut corners. If you're interested in looking at stuff like that, yeah, this little scalability article is quite interesting. But again, the short version of it is there's some places where you can cut corners where data integrity doesn't matter that much. And if data integrity doesn't matter that much, but user perceptions of quality of service do, are you able to load videos quickly, have them run quickly, that sort of thing, then lean towards that, right? As opposed to leaning towards perfect data integrity. Okay. Now, YouTube's core system, core database, is a scalable extension of MySQL called Vitess. MySQL is a relational database system. The big thing that's interesting about Vitess, okay, number one, it's a relational database system. We'll talk about that in a moment. But it tries to avoid pushing through duplicate queries. When I say horizontal sharding, that means if the amount of data that's stored spills over into new machines, it's going to automatically integrate that. So a lot of relational database systems, having the tables spill over into multiple pieces of hardware would be a bad thing. Here, they manage it because videos are so large and YouTube stores so many of them, there's no way you're going to have those tables of videos all stored on one piece of hardware. But query duplication, query parsing, we'll talk about that for a minute. So, interesting feature you can include. Suppose I have a set of videos, right? And I say, top songs of, I don't know, 1980s, okay? Now, who's going to be in 1980s? Well, you'll have all the big people from back when, of course, Madonna, I guess, who else? Prince, you'll have Michael Jackson, and George Michael, and of course, Whitney Houston, and many others, right? So if I do top songs of 1980s, I'm going to get a batch of stuff like this. But it's possible there are going to be subsets of this, right? For example, if somebody does searches for, say, top songs 1983, for example, right? Then, of course, some of this stuff, right, well, basically takes a query of the earlier query results. Essentially is what's going to happen, right? So everything that's in top songs of 1983 would be a subset of top songs of the 1980s. So that sort of query parsing, here's where it becomes important. If, for example, suppose for some reason, suppose that this query is locally popular, okay, and the results are already cached at some data center. Then, if YouTube can recognize that the second query, right, top songs 1983, is a subset, a subquery of the original cached results, then it doesn't need to run the query through its own databases. Okay? And this is very, very useful because quite often, users will get the same or very similar batches of videos from slightly different queries. Okay, this is analogous to Google's semantic understanding of terms. Basically, if two queries return the same set of videos, then they are functionally identical. Okay, so that's one of the things you get with Vitess. It automatically does this sort of breaking down of queries to see, is this query a subunit of another one that I might already have cached? And that's something that puts a lot less load on the system, right? And similarly, it says, is this query equivalent to one that's already been run recently and I can find results for? And thus, there's no reason to run the new query separately. Okay. Now, again, on this, why is a relational database system even viable? Everything we've talked about suggests that if you're doing video data where the data requirements are wildly divergent for individual records, it's not going to work well. It's going to be a lot of dead space in the database. Well, part of the reason why YouTube, number one, it stores standardized metadata. So all the things that it stores about the video, like links, keywords describing the video, like the artist, the year, the time, the genre of the music, that's all stored as standardized metadata formats, and that naturally fits with the relational database model. The other thing, Dash, as we talked about, Dash delivers video segments. It doesn't deliver the entire video, it delivers individual video segments, and those segments can be standardized pretty well prior to viewing. And those, again, both of those kinds of data can be stored in relational databases with fairly high utilization and performance. The reason why you wouldn't just want to store a simple key value store for all these video chunks is because then it would be difficult to run queries across different tables, right? But here, right, if I have two indexes for the data, for example, two or more, index 1, the artist, index 2, the album, or index 3, the style, or index 4, the year, with the data indexed in those different, along those different variables, YouTube can run queries across tables, right, based on various similar attributes, right? Things like show me all videos from 2012, or show me some stuff by Taylor Swift, right? Whatever. Okay. And that's something, again, this sort of global system query isn't really possible in Facebook, for example, right? In Facebook, you can see all photos posted by one of your friends if you look at their profile, or you can see all the photos posted recently by all your friends, right, in your feed if you scroll down enough. But you can't simply query Facebook to ask, show me all photos posted in Chicago during October 2020, right? There's not a mechanism to do that. In YouTube, because the needs for what the users have, YouTubers want to be able to run queries like this. YouTube had to design a slightly different system than what Facebook has. It has, you know, extra querying opportunities that aren't really necessary in Facebook. Okay. Now, why wouldn't YouTube use NoSQL, right? That's the second thing. So sure, okay, a relational system can work, but what's the downside of using some kind of NoSQL system? Well, the short answer, NoSQL probably would be a more efficient way to store the data, and that's important, but YouTube has to deal with issues beyond just simple storage. First of all, compression, right? We know with videos, they're going to be stored as segments, and those segments are generally going to be compressed so they can be, the content can be delivered faster to the end users. And if you stored entire video files that might be a gig or more of data, if you stored them as just data blobs, as key value pairs, it would be really difficult to get non-sequential access. Basically, if you stored it as one single, you know, gig-sized unit, you'd have to lift that entire thing, deliver it, which is going to take a while, unpack it when the user gets it, and then, only then would you be able to say, move ahead to the middle of the video. If the video is already pre-segmented, then of course that becomes less of an issue. You know that an individual segment starts at such and such time in the video. The other thing, again, YouTube wants to allow table joins in the video search process. Just like I talked about a second ago with the queries, people might want to see videos by a particular artist or from a particular album or uploaded by the same user. All those are not going to be easy to do in a NoSQL system that's typically going to be just about retrieval and not about allowing queries across tables. So again, contrasting with Facebook's Haystack, you know, with Facebook's photo system, you can see all the pictures by one user because that's how they get stored, or Facebook already has recent pictures pre-delivered into your feed. You can look at those, but you can't just get, you know, a global slice of photos according to some user-specified query criteria across the entire Facebook system. Facebook doesn't let you do that because they're using a NoSQL system where you can't run those kind of cross-table queries. Okay. So that's it. That's a bit about YouTube's databases. And the rest of this is about cookies. So I'll take a moment. If people have any questions or other issues, anybody want to talk a little bit about YouTube's databases? Here I am. In the chat, I suppose. I think I've disabled people to talk. I could enable talking. Anybody have anything to say? There you go. What's happening? Nothing? You're all still here, right? Haha. I guess I'll never know. Okay, well, we'll get back to it. Oh, there we go. YouTube. Yeah, I mean, I don't know specifically about that system, but here's the thing. If you just stored, and let me, I guess I'm still sharing, aren't I? Let me make sure. Yeah. Right. If YouTube stored everything as key value pairs, right? So here's some table. Right? And each one of these videos is basically stored as some big blob inside the database, right? It's going to be more efficient because I can just pack them in. As soon as one video ends, I pack the next one, right? But the problem is fast forwarding is a big one. So if I don't watch the whole thing, how far into this compressed video do I go? Because it can be unevenly compressed, right? So for example, is uneven. Could be much compression at the start and end when there's less activity, little compression in the middle, or vice versa. You don't know. Okay, so that's one issue. The other is if I'm storing all this data like this, since key value store doesn't have a uniform set of fields across all records, I have to dig around inside each record to find whether that data is even there, right? And then where to find it. So if I use a relational database, right? So if I have something like a list table of videos, right, which is not actually the content, but something like user who posted and video ID, and then some other stuff, maybe the date. Okay, and then I can use that to reference another table of the video metadata, right? So I have things in here like artist, album, year, etc. You know, to the point that those are relevant. Obviously, not all videos are going to have that, but then I can say, oh, okay, here's the reference, right? I can reference a particular video and a particular user, and I can run some sort of multi-table query on this very easily, as opposed to if I just bundled up all that data together into a blob, delivered the blob. Yeah, it would be more efficient in terms of storage, but I'd lose the ability to do these kind of nice cross-table queries. Yeah. Does that make sense? I hope it does. Yeah, good. Okay. Anything else? I mean, they're coming up with tech faster than I can, honestly, faster than I can keep up with it, because I have, you know, my primary job is being a professor, not so much being an IT guy. So it's an interesting problem. This is something that happens in the department generally. People are usually pretty knowledgeable when they first get hired, and then as time goes on, you know, they're still pretty knowledgeable about stuff that happened 10, 20, 30 years ago, but as far as what's going on this year, it's kind of dicey. Anyway, circle of life. But the principles, they don't change that much. The big issues, you know, they change a lot slower than the number of platforms or what they're called or who's using them. So we try to give you a good background of the stuff we know about. And of course, you guys are going to go out there and eventually get some practitioner skills and learn more about current things than we do. So, all right, very good. So the last thing to talk about then is cookies. All right, so cookies are small files stored in your web browser by a lot of sites if you permit it, right? Generally, you'll go to a site that has them, and there'll be some disclaimer that says, this site wants to put a cookie on your machine, click accept to accept. In general, there's only going to be one cookie per profile or browser combination. And ordinary cookies don't store information to identify users across devices. So, example one, if I'm running Chrome and Firefox on the same laptop, even if I visit the same site, I'm going to get separate cookies from that site for each browser. Likewise, if I have two laptops and I run Chrome on each of them, each laptop is going to have a different cookie from that website. Now, what are cookies? Again, small files, small data files that store whatever information a particular site thinks is important. So there are some standard elements to them, but sites can specify what is stored and how it's going to be interpreted. The data is typically going to be stored as some mix of plain and encrypted text. In many cases, cookies will have a little bit of plain text and a lot of it as encrypted. So if you're interested, for example, you can find where they're stored. Not that anybody uses Internet Explorer anymore, but if you did, you could look up in that folder where your stuff is, see what cookies you have from what various sites. And here's an example. So this one, right, if we look, this is, I visited a site, udacity.com, and I changed some characters throughout. So you can see here this A became a Q, and there's some other random letters scrambled around in there. So whatever that cookie is, you're not going to get anything out of it. Anyway, but you can see there's definitely some standard things, right? So when we see here UI, that's from Udacity, visitor, there's a visitor ID, that's me. You can see I visited at a certain time, right? 2015, December 30th, and then there's some kind of time window in there. And then this other stuff is all a bunch of scrambled data that I don't know what that is, okay? It's just a bunch of encrypted whatever. It means something to Udacity, but to me it doesn't mean anything. So again, what it's including here is the name of the site, just that's some kind of check when Udacity is looking at the cookie, just to verify, is this in fact our cookie? And then there's some standard stuff about the visitor ID, and the rest of it is all just a bunch of custom encrypted stuff that we don't really know what it is. So again, this is fairly typical to have a little bit of plain text in there, but most of the data is probably going to be encrypted because some of it could be sensitive and you want to keep the bad guys from being able to do anything with it. Okay, how do cookies work? Well, if I first visit a site, that site is going to install a cookie on my device that has some session information about me. For example, if I go to YouTube, the first time I go there, if I've cleared all my cookies, like you saw me clear my browser history, and I go to YouTube and it looks for a YouTube cookie, doesn't find one, says, oh, hey, welcome aboard. Here's your first time at YouTube. Okay, I'm going to put a cookie on you. Then, as I drift around the site, go to other pages on the site, in the case of YouTube, clicking on other videos, that cookie becomes the proof of login to access other pages on the same site. So if I've logged in as myself on YouTube, then YouTube says, oh, this is who you are. Great, you can stay logged in even as you go from one page to another. You don't have to re-log in on new pages. And for subsequent visits, I don't have to provide that information manually. So I can stay logged in even if I haven't visited the site in a while, because the cookie will still retain my session information. Typical things that get stored in cookie, for example, user ID and passwords. Obviously, passwords are sensitive data. They will generally be encrypted, right? They don't have to be, but it would be pretty foolish not to. Other things, site preferences, probably not that important to keep encrypted, but maybe they do it anyway just to make it harder to isolate where the password is stored in the cookie. Other things like recent user history, like any searches you've done or any pages you've visited on the site. For a case of something like Amazon, Amazon will store your shopping cart contents in a cookie so that, you know, if you visit Amazon, add a few things to the cart, go away, come back the next day, you'll see your cart is probably still active. So things like that, that's the sort of stuff that cookies store. We might ask, why are cookies necessary? Well, the short version, a lot of web applications are what are called stateless. Stateless applications, they don't record the state of the users involved. So they treat every interaction with the user in the same way, regardless of who the user is or what they've done previously. Basically, they assume that the site or the application doesn't know anything about the user. However, another kind is stateful applications. A stateful application will group a bunch of actions by the same user together into what's called a session. And again, typically that's done with cookies. So the cookie provides a file that records the information about that user so that the application can recognize who the user is. Now, way back in the early days of the internet, right, so think early 90s, HTTP was stateless, but has since evolved to include some stateful features. So in many ways, it does keep track of who you are. So, simple example, suppose a server receives requests over the internet. Suppose it's a web server that's delivering a web page. When it receives a request over the internet, it shouldn't, in a stateless application, respond differently depending on who the user is. It just sees, oh, here's a request for the web page. I will send that, I will send the response out. I will send the web page out to the address that requested it. Now, if you were going to keep information, right, about who has been launching repeated requests to that site, you could store that in a couple ways. One possibility is keeping it on the server side, right? So updating a database for every user action. But if you're doing that and you have a big site like, say, YouTube or Amazon or Google, keeping that on the server side is going to be a lot of work. It's going to create bottlenecks in your IT processes. If there's a busy time where there's a lot of users using the system, there's going to be a lot of updates that have to happen to that system. So because of that problem, it's often more scalable to keep the information on the client side. That way, you don't have to worry with a sudden flood of users all trying to access this server where all the information would be stored. Instead, every user who visits the site, the relevant information is actually stored on their machine and can be processed locally that way. So typically what happens, something like this, I'll walk through a little process. And there's a web server, okay? So just like we said, there's a web server that gives pages. Here's me, here's a user. I go to the home page, okay? At the home page, right? So I call up to the web server. I say, give me the page. Web server sends the page back. Okay, so request and response. The web server sends the page back. Plus a cookie, right? So the web server stores that cookie on my machine. Says, okay, I know who you are. So time goes on. If I come back to that machine and go to, say, a different link from that home page, right, so I'll say travel to second page on same site. A simple way to do that is along with the new URL, right, I append not only the new URL for the site, plus relevant cookie data, right? So, and that cookie data contains my session information, so the web server knows who I am. So when the web server responds back, again, sends response, no need to recheck the user's login status, right? Because that was already sent along with the page request. All right, so again, that's a fairly typical way to use cookies. Now, how it works on YouTube? Well, first of all, standard HTTP cookies are limited to about 4K of data, which, you know, depending on what you're doing, it could be a lot, but for some applications, it's kind of limiting. So for example, if YouTube wants to keep a lot of data about what videos you've watched, right? You have information about the video you watched, you have information about how long you watched it. I guess that's it. But if they want each one of those, that could be easily, you know, something like 50 bytes of data. So with just, you know, not even 100 of those, 100 videos, you would quickly exhaust the available cookie space. And that's not even talking about site preferences or other things, or passwords or the current session key, whatever. So because of that, it's going to be small. So YouTube keeps multiple cookies per user. So one reason is tracking all these session details, like information about currently watched videos, where your current segment that you're watching is. So it's kind of neat. If you go away from YouTube and then you come back and rewatch a video, it'll bring you back to approximately the same point where you stopped watching it. And it does that through cookies. And again, holding user preference for unlogged users. So YouTube wants to use multiple cookies because, yeah, typically 4K is not nearly enough for what YouTube wants to store. Now, even if websites aren't using so-called, you know, even aren't using HTTP cookies, they're often using other technologies, other recording mechanisms that perform the same function as cookies. So one of them is something called a delayed cookie. A delayed cookie is a kind of long-term cookie that wasn't associated with a particular session. So it was just sort of a global information repository. That's similar to what YouTube is doing if it has a long-running list of data about a user. So the delayed cookies were back when used with Flash Player, and they were a little bit difficult to find, a little bit difficult to delete. So a lot of people who were very privacy conscious were concerned about that, because not only were cookies a little bit scary to some people, but on top of that, they couldn't even find them and get rid of them if they wanted to. So when they clicked the standard delete option in the browser, it didn't necessarily get rid of these cookies in Flash. Likewise, we have an old article here. We'll see how well this works. So this is from 2009. Yeah, this is 10 years ago again. It's an old article. Recently implemented delayed cookie privacy feature at YouTube. When is a cookie not a cookie, right? So this same kind of thing, YouTube says, okay, we're going to stop using cookies, but instead they put in this new recording feature, a delayed cookie that basically does exactly the same kind of thing as a cookie did. It's just not a cookie. It's just a different kind of data storage file for keeping information about the users. So yeah, even if you got rid of cookies themselves, all these websites, in order to achieve this sort of operation, that you can go to different pages on a website without having to re-log in at every page you go to for this kind of stateless application, you would still need some mechanism for storing your session key so that you could go on to another page on the same site without having to log in again. Okay. Now, cookie security risks. So interesting thing, may surprise people, HTTP cookies were first introduced in the mid-90s. At the time, unless you were a technical person, you probably had no idea what cookies were, how they worked. Mid-90s, most people did not know much about the internet. And cookie acceptance was a default browser option. So anytime you went to a website and it wanted to put a cookie on your machine, it could put a cookie on your machine. So the problem happened when some of these security vulnerabilities around cookies began to come out. There was a lot of backlash against it because people had the sense that this technology is flawed, it's dangerous, there's problems with it, and it was basically forced on people, right? Because it was a default browser option, it was forced on people, they didn't know how to opt out of it. It definitely elevated the perceived risk. Now again, because information in cookies is potentially sensitive, cookie data is more often encrypted than not. And there are things you can do to mess with cookies, right? So I have some older articles down here about, for example, tampering with the contents of a cookie, hacking cookie data to try to find passwords, hackers using forged cookies to access other people's accounts. There's some things you can do, there's some vulnerabilities with cookies, but my point is it's not specific to the cookies themselves. Anytime you store keys to access something, there's a possibility that some bad guy could get it, right? So anytime you're using a password to enter a website, unless everything you need is right on that page, you're going to need to reuse that password to go to other pages on that site. And either one, you have to deal with that pain in the ass where if you want to watch different things, every time you go to a new page, you have to log in. People don't really want to bother with that. Or you store the password locally on your machine and hope that nobody else gets access to it. Well, of course, if you're storing it on your machine, if you're storing it somewhere, there's the possibility that the bad guys can get hold of it. So not inherent to cookies, but it is inherent to any sort of stored password mechanism. All right. Anyway, cookie types. So 3 cookie types worth knowing, right? And when I say worth knowing, you can pretty much assume that they will be on the final. So the first is a first-party cookie. When people say HTTP cookies, these are what they generally mean. So first-party cookies used by the same website you're visiting, right? So for example, first-party cookie. I go to Amazon, log in, buy some stuff, log out. Amazon puts a cookie on my machine. When I return, Amazon uses that cookie to automatically restore, let's say I don't log out, to automatically restore my session. Okay, so a first-party cookie, it's used by the organization that put the cookie on my machine. Okay, nobody else, no other site will use that cookie's data. Okay, a third-party cookie is used by another site. Right? So here in the slides, used by the cookie source to track you across other websites. Okay, so for example, I go to Amazon again, log in, add some stuff to cart, don't buy it, and leave, but stay logged in. Okay, Amazon puts a third-party cookie on my machine. When I visit other sites that use Amazon's advertising API, right? Those other sites can access the third-party cookie to see what items I recently viewed and include them in ads. Okay, so Amazon, the cookie is used by other organizations than the one that placed the cookie. Okay, that's the difference. First party cookie, if Amazon put it on my machine, Amazon's the site that's going to use it. A third party cookie, if Amazon put it on my machine, some other sites can still use it. And you know, they have a legitimate reason to use it in order to show me more interesting, relevant, profitable ads. Okay, last one, super cookies. So super cookies, excuse me, aren't true HTTP cookies, but they serve a similar role of storing information. The difference is they gather information across sessions, across different websites, even across browsers. So for example, if I have my same information stored at Google, Google wants to integrate that information for all the stuff I've done, right? So whatever browser I'm using, different sessions over time, Google wants to compile all that information about me together in one place. And they do it by essentially having what's this thing called a super cookie, which takes all of these little cookies that might be stored around different Google sites or running on different browsers or on different machines, and as far as Google can, it's going to combine them all together. Okay, now what's going on the horizon? Well, number one, they're still useful, but they're not nearly as useful as they used to be. So back 20 years ago, most people, if they had a computer, they had one and they used it. Of course, these days, users typically have multiple devices, right? We got phones, we got laptops, we might have a desktop at home, we got maybe other people's machines that we're borrowing. So each cookie that you have has only partial information, right? It doesn't have the entire history of a particular user. And of course, people nowadays are more privacy conscious than a lot of them were 20 years ago. So many users will block or periodically erase cookies, which splinters your profile data even more. So then it's no longer just the device or the browser that you're using. It's also you only get a slice for a particular time between your cookie deletions. And last, for a lot of things, apps are starting to replace ordinary browsing. For example, some of you might have the Amazon app or you might have an eBay app. So instead of going regularly through the internet, you just use, instead of going through a web browser, use the app to access whatever data you want to get. And again, those cookies, they're not going to be quite as available to other things. So you'll still record information about the user within the app, but you're not really doing it in a standard cookie anymore. One of the things that's starting to replace cookies, something called fingerprinting. So fingerprinting tries to identify users by the unique combination of browser, operating system, hardware features, and eventually perhaps behavior, like the sites you visit and what you do while you're on them. Now, this one, this is an academic paper, research paper. Let's see what we find here. All right, again, this is from a few years ago. What year was this? 2014. So this has been around for a while, but this is the first studies of the advanced web tracking technique called fingerprinting, right? They found that even in 2014, over 5% of the top 100,000 websites employ it. So, you know, and that was 6 years ago. There's surely a lot more websites doing it now. So even if cookies aren't quite the mechanism for tracking users that they used to be, Well, fingerprinting is surprisingly effective. I don't know what happened there. Bad shit. Okay. So, my point is for all this, oh, I see. Even though cookies, right, they're getting watered down, they're not as useful as they used to be, still, the need to track users for a variety of legitimate purposes, that need is not going away. And if cookies start to fade out, some other technology will surely roll in to fulfill the same role. Okay. So that's it. That's all my stuff for today. That's all I got to say. Any questions on any of this stuff? The FAQ and the topics of interest, they're posted up on Blackboard in the lecture sites now, so you can go check those out. And then on Thursday, we'll have our review session. So if you have questions, stop on by and we'll talk. Don't panic about the final. Historically, the YouTube one is the one where students do the best. I mean, still prepare and study, but yeah, usually classes do reasonably well on the YouTube module because they're starting to not only understand how to study for the course, but they're also pulling together a little bit. A lot of the different things that YouTube does are in some ways like the other features of Amazon or Facebook or Google. So even if you didn't 100% understand it then, this is a second time around for a lot of those topics. Okay, last call for any questions? After that, yes. So whatever your lowest score of the 4 exams is, it will be replaced by your average of the other 3 scores. Okay? So yeah, we still drop 1. All right. Well, if there are no further anythings, then that's all I got. And it's been a hoot. And I'll see many of you on Thursday, I suppose. Yes, TAs are having office hours. They should also be available during the scheduled lab sessions. There just isn't a lab session, but most of the TAs should be available to talk about anything during the labs.